Hi, welcome to this video. In this, we will delve into the second part of operators in Java, binary operators. Unlike unary operators, which work on single operand, binary operators operate on two operands. Understanding these operators is crucial because most of the operators you'll encounter in Java are binary. They help perform operations ranging from simple arithmetic to complex logical decisions. They are the essential building blocks that help us to manipulate data and make logical decisions in our code. Let's explore a few categories of binary operators, which includes arithmetic operators, relational operators, bitwise operators, logical operators, assignment operators, and short circuit operators. The first, arithmetic operators. They perform the basic mathematical operations on two operands. For example, if we have two variables a and b, the addition operator will add a and b. The subtraction will subtract b from a. The multiplication operator will multiply a and b. The division operator divides a by b. The modulus operator gives a reminder when a is divided by b. These operators are straightforward but fundamental when working with numerical data. The second on the list is relational operator. Even in the relational operator, it will be working on two operands. Relational operator will compare two values and return a Boolean result, either true or false. These are essential for decision making in our programs. For example, equals to will check if A is equals to B. Assuming we have the same two variables A and B, like our last arithmetic operator example, even in the relational operator, we are considering the A and B in this as well. So for equals to, it checks if A is equals to B, and if not equals to, checks if A is not equals to B. Less than symbol checks if A is less than B. Less than equals to checks if A is less than or equal to B. Greater checks if A is greater than B. Greater equals to checks if A is greater than or equal to B. So relational operators are widely used, mostly in situations like where there is if statements and loops to control the flow of your program based on the condition. The next on the list what we have is logical operators. Logical operators will be combining Boolean expression and return a Boolean result based on the logic of the operands. And returns true only if both the operands are true, or returns true if at least one of the operand is true. For instance, if you have two Boolean expressions A and B, the expression A and B will only be true if both A and B are true. On the other hand, A logical or B will be true if either A or B is true. The next one on the list for us is bitwise operator. Bitwise operators works on binary representation of integers. They perform operation at the bit level, which can be very efficient for certain states. The common bitwise operators will include AND, OR, and XOR. So the bitwise AND, each bit is compared and the result is 1 if both corresponding bits are 1. The result is for the OR operator, the result is 1 if either of the corresponding bits is 1. And for XOR, the result is 1 if the corresponding bits are different. Additionally, there are also left shift operator and then right shift operator. So left shift operator shifts a bit of a number to the left by the specified number of position. And the right shift will shift the bits to the right. For example, applying Left shift to 6, which is 110 in binary, by one position results in 12, which is 1100 in binary. So all these operators that I'm explaining and explaining the theory of it, these would be better understandable when we'll practice it in the program session. So let's look at the assignment operator. So assignment operators are used to assign values to variables. They can be simple or compound. So simple assignment is equal to symbol. So simple assignment will directly assign a value to a variable. For example, x is equals to 5 assigns 5 to x. Compound assignment combines assignment with an arithmetic operation. We would have seen the arithmetic operators at the very beginning. So the arithmetic operator is like addition, subtraction, multiplication, division, and modulus. So compound assignment is going to combine the simple assignment, which is equals to, with the arithmetic. For example, x plus is equals to 5 is equals to x is equals to x plus 5. Compound assignments make your code more concise and easier to read. The final one we have for the binary operator is your short circuit operator. Short circuit operators are special form of logical operators that stop evaluating as soon as the result is determined. For example, in the case of AND, which is short circuit AND, if the first operand is false, the second operand is not evaluated because the overall result will always be false. In case of the OR, in the short circuit OR, if the first operand is true, the second operand is skipped because the result is already true. This behavior is called short circuiting because it avoids unnecessary evaluation, making your code more efficient. So to sum up, binary operators in Java are essential tools for performing operations on two operands, from basic arithmetic operation to complex bitwise manipulations and logical decisions. These operators are the backbone of how Java programs process data and make logical decisions. Let's now move on to the practical demo to see these operators in action.